the dark of night, the stars light up the sky. We see them flying free. That's just like you and me. Everyone is lonely sometimes, but I would walk 1,000 miles to see your eyes. You are not alone, we are family. Hold me like the
So let's dive into this mechanism. Briefly, we understand how clouds are formed in the atmosphere, how they become charged, and then eventually we get into the situation of the lightning conductor, how it works in order to prevent the houses or those tall, pear-shaped surfaces. What I mean, the buildings, the trees, and just in case they are installed in such a building that is in the vicinity of the lightning, how it helps to control the house from the dangers. So the theme is electricity and electromagnetism. And then the topic is electrostatics. And basically I want us to discuss on cloud charging. How does the cloud become charged? And then eventually we shall dive into the lightning formation and prevention. How clouds become charged. How clouds become charged. So we have 3 steps we follow, or 3 stages we follow to master the mechanism of cloud formation and charging. And the secret behind this charging is by friction. So this is what happens. We have the evaporation and cloud formation, charging of clouds, then the discharging process from the clouds. So let's start with the evaporation and cloud formation. Evaporation and cloud formation. And then finally we shall get into the charging process. So in the atmosphere, all this takes place in the atmosphere. Now the ground is made up of very many large water bodies, and the ground itself during the times is always hot. I know that the hot water on the surface of the earth creates what we call hot water vapor, and that hot water appears in hot air, in form of hot air. Since air is of a less density, that hot air or hot water vapor escapes to the atmosphere for the fact that it is of a less density. Now, as it escapes to the atmosphere, it accumulates on a certain level in the atmosphere. It accumulates in the atmosphere. Remember, it is coming from the ground where the ground is hot. Then on a certain level of the atmosphere, it again accumulates, but with smaller droplets or water droplets in the atmosphere. And these smaller water droplets accumulate in that level of the atmosphere, and they continue to move towards the far ends of the atmosphere, from far from the earth. They move far from the earth, given the fact that they are not as such more dense, so they escape to the atmosphere, to the far levels. Now in the atmosphere they form what we call clouds, but for this case they are already condensed with a temperature, condensed to a temperature of about 0 degrees Celsius. Now these water droplets form cubes of water molecules. The cubes of water molecules are condensed to that temperature of 0 degrees Celsius. And for that case, already a cloud formed. So that is a cloud formed. Now examining how the cubes of the water droplets that are already condensed to about 0 degrees Celsius, examining how they become charged. Remember, they are in that random motion. So when one cube of water loses its electron, it becomes light and remains with excess positive charges. So the lost electron is acquired by another cube. So that cube becomes more negative. And that for that case it becomes massive, or it becomes of a bigger mass. So we can basically see that a cube loses electron, becomes excess positive, excess light. So the excess electrons are acquired by another cube that becomes excess negative, which is light. Sorry, excess, I beg your pardon, excess positive, negative, and becomes massive. Now the negative being of a mass greater than the positive, they condense below the cloud. So that's why we see the negatives underneath or below or towards the earth, towards the earth's surface. Then the positive of light weight, they condense on the upper part of the cloud. But they must be of equal size and magnitude. So we can see positive and negative formed on the cloud. So that is how a cloud becomes positively charged and negatively charged on the either ends. So basically, to summarize everything, we can see that the process of cloud formation starts from the ground level, whereby the hot water, how does the hot water formed? During daytime, light from the sun sends the radiation to the earth, and the radiation increases the temperature of the water. Remember the water bodies on the earth, the lake, the oceans, the seas, and all that. This hot water starts to evaporate, meaning in form of hot air or in form of water vapor. And this water vapor is of less density or is of less mass, so it escapes to the atmosphere, and in the atmosphere the water droplets are formed, but of a less temperature, about 5 degrees Celsius, 2 degrees Celsius, 4 degrees Celsius, relatively about greater than 0, but not actually greater than 5 and above. So for that case, that temperature of the water keeps on condensing as it escapes to the atmosphere, until when it forms condensed ice cubes of the water of a temperature about 0 degrees Celsius or less than 0 degrees Celsius. Now these ice cubes are in random motion. They are in zigzag motion. Now when they collide, taking a case where we have two ice cubes of water or cubes of water, now of a temperature less than 0 degrees. On collision, one ice cube loses an electron and it becomes very light, or it becomes lighter. For it remains with excess positive. Then the negative lost is gained by the second ice cube, and for that it becomes excess negative, and excess negative, I mean. So it becomes more massive, and for that case, the cloud is formed within, I mean, the charges are formed within the cloud, and where the negatives condense or of a higher mass are condensed at the lower part of the cloud, and the positive of a lighter mass are condensed at the upper part of the cloud. So throughout this mechanism, we can see that a cloud is already charged. Now, in the next export, we are going to check how or what happens when this charged cloud, taking a case of the negative part of the cloud, passing over sharp points, passing over peer sharp points. And for the case of a lightning conductor placed in that sharp point, how does this cloud react with the conductor? Well, thank you so much for listening. Thank you so much for watching. I wish you all the best. Kindly take care of yourselves. May God bless you as we share this knowledge, as we stay as a family. Of course, we are united. Thank you so much. I love you. Bye bye.